So what we want to remember is how we find solutions to a quadratic equation. Now, we know we've got three ways that you would have learned about at some stage. The more common ones are the factorisation and the quadratic formula, but you've also seen completing the square. So there's the three ways that we can solve a quadratic equation. Now, these are the most popular ones. If we can factorise, we'll factorise first, then we'll go with the quadratic formula. Very rarely will we complete the square as a method of solving a quadratic equation, but it does come up as a way to solve, as a necessary way to solve some of the problems we'll face with locus in this topic. So what are we going to, well, how does this work? We're reminding ourselves x squared minus 2x minus 15 equals 0. So factorising those two, we know the two numbers here multiply to give us 15, but add to give us minus 2. So we get both of these must equal 0, so x was equal to 5 or minus 3. And the quadratic formula, or minus b plus or minus the square root of b squared minus 4ac all over 2a, and we start to clean up our numbers and we get our 5 or minus 3. And if we remember our completing the square, we'll take our 15 across to the right hand side. We're going to complete the square, so half of 2 gives us 1 and 1 squared gives us 1 there. So that the half of minus 2, that becomes our minus 1, and the minus 1 all squared gives us the positive 1. We add 1 on both sides, and so we get 16 on that side. Take the square root of 16 is plus or minus 4. Add 1 on both sides, so we get 1 plus 4 and 1 minus 4, which gives us our 5 or minus 3. So there's our three methods, and we can solve equations using any of those three. Sometimes we're not going to get nice factors, so the quadratic formula comes in, but you could use these ones really any time we like. So here's a question where we want to show by completing the square and the quadratic formula that this equation has no solution. So, well, how do we do that? Well, the steps of completing the square mean that we take the constant across to the right hand side. We've got a minus 9 there. We go to complete the square. We take our 4, we halve it, so it gives us 2, and 2 squared gives us 4. And then we get the 4 on both sides, because what we do to one side, we do to the other. That gives us minus 5. But now our next step is to take the square root of each side, but we can't take the square root of a negative 5. So that means there's no solutions there. We can't find any values of x that would make that equal to 0. And we can see that when we do the quadratic formula. So we get the negative b plus, take the plus or minus the square root of the 4 squared, minus 4 times 1 times 9, and 4 times 1 times 9, taking that away from 16 gives us a minus 20. Can't take the square root of a negative number. So that's where we start to see there's no solutions, because we can't get any x values in the real number system. By manipulating this one, can we, if we're still playing with this equation, x squared plus 4x plus 9, can we show that it's equal to this expression? Well, let's take that expression, expand it out. So x plus 2 all squared gives us x squared plus 4x plus 4, plus the 5 gives us what we wanted on our left hand side. So when we look at that, we look at, can x squared plus 4x plus 9 ever be equal to 0? Well, we know that x plus 2 all squared, that's going to give us a positive number every time, no matter what we put in. It's going to be a number that's going to be greater than 0. We're going to add 5, so it's always going to be greater than 0. And it can't be negative either. So x squared plus 2 all squared, well, whenever we put in there, it's always going to be a positive number. Plus 5 is going to be greater than 0. So it's never going to be negative, it's never going to be 0. So what is the least value that we would get? So if we investigate that expression, x plus 2 will have a minimum value of 0. And that when x is equal to minus 2, that makes it 0 there. So it's always going to be greater than, and at least equal to 5. So it's a minimum value overall of 5. So that's the smallest value, that's the least value that we can get. So if we sketch x plus 2 all squared, what does that look like? Well, that looks like a parabola, concave up, which touches the curve at x is equal to minus 2. It's like x squared, and because it's x plus 2, it shifts it across 2 units. But if we compare x squared plus 4x plus 9 and write it as x squared, x plus 2 all squared plus 5, that's that parabola shifted up 5 units. So instead of going through minus 2, 0, goes through minus 2, 5. So it's the same parabola. It's just been raised up 5 units there. So something to keep in mind. If you've got a quadratic that has roots, okay, or zeros, and that's where it goes through the x-axis. That's what we're going to start calling the values. So it goes through the x-axis, and alpha and beta are those roots. Then the equation of the quadratic can take this form. And how many equations can it have? Hopefully you're thinking it's got an infinite number of equations, because it just depends on what the value of a is. And a can take on any number. But if we look at something like this, what equation could it have? Well, it could have an infinite number of equations because it goes through these values. We've got no values on the y value, on the y-axis, so we don't know where it is. If it's monic, then it would have 1 as its coefficient of x squared. So if it says mnemonic, there'd be x minus 1, x minus 5 as our brackets. So if we want to write down the general form of mnemonic quadratic, for which one of the zeros is x is equal to 1, find the equation of such a quadratic in which the curve passes through the origin. So it would look like that. It would have x equal the 1 out the front, because it's going to be 1 times x, and x minus 1, then x minus some value alpha, so it's another equation. That's what the general form would look like. But this time, if it goes through the origin, then that value must be equal to 0, so we get x times the x minus 1, or x outside of x minus 1. So that's what our parabola will be in this situation. So the general form of a quadratic would look like that. And then if we've got a quadratic that passes through the origin, that would have to be equal to 0. So we get that as our parabola. So that's what we start to look at. The idea of what are the roots of a parabola? How do we get the roots? Well, we can get our quadratic, we can get our solutions of a quadratic equation. But we don't always want to get the solutions to a quadratic equation. And that's what our next videos are going to be about. Not actually finding the solutions, but working with the idea of how many solutions we would get, and we call those roots of a quadratic equation.